Hey everyone, welcome to another segment in Aggregate Expenditures, Chapter 6E. This segment, we're going to add the government sector to our simple model. So recall that our simple model was just aggregate expenditures is consumption plus investment. And with that, we were able to find expenditure equilibrium from a table where AE equals Y. We were able to find expenditure equilibrium using the mathematical formulas, doing the same thing. AE equals Y. And we were able to find it graphically where we drew the aggregate expenditure function and found where it crossed the A equals Y equilibrium 45-degree line. So we really don't do anything new. It changes things a little bit when we add the government sector, but you'll see that the way you calculated the multiplier, the way you did all the analysis, the way you did the graphics is all exactly the same. Okay, let's take a look at how we add the government sector. First of all, we have to assume that government spending is autonomous, which means it's independent of the level of income. The way to think about this is that the government comes out once a year, sets its budget, plans its government spending, and tries to stick to it. So if the economy goes up or down, largely government spending won't react in a predictable way. So we basically say that government spending is autonomous because they fix the plan at the beginning of the fiscal year and try to stick to it throughout the year. Taxes, on the other hand, also has an autonomous component. That would be user fees, for example, or property tax. So those are basically fixed no matter what the level of income in the country is. But there's also an induced tax. That one's not too hard to remember. As the level of income goes up, taxes go up as well, as we all know too well. So then we define something called the marginal tax rate. This is very similar in concept to the marginal propensity to consume and the marginal propensity to expend, which we've already defined in previous sectors. So it is the ratio of the change in tax as a result of the change in income. So the marginal tax rate is the change in taxes divided by the change in income. And we'll see when we graph the tax function that ends up being the slope of the tax function, which shouldn't come as too much of a surprise given how we looked at the MPE and the MPC from earlier segments. So let's take a look at this table and see what we can draw from it. We've got our same old national income rising in our example that we've seen many times before. But here now we've got tax revenue. And we show that that also rises with national income. Remember, there is that autonomous portion of the tax revenue function, but there's also the induced portion, which rises as the level of income rises. So that makes sense. Then we've got government spending, and we said that was autonomous. So it stays at 160 throughout the entire range of possible national incomes. That's how we model this up. Now, the other thing we want to do is calculate the budget. So here we're showing that government spending is autonomous at 160. But let's take a look at this budget. Well, to find the budget, whether it's a surplus or a deficit, we simply take the taxes we received minus the government spending. And if you always do it that way, you'll get the sign right. So here taxes are only 60 and government spending is 160. So we've got a budget deficit of 100. It's negative to show that we're spending more than we're taking in taxes. Now, of course, as tax revenue rises with income rising, we're going to get a greater amount of tax number, but subtracting the same fixed amount of government spending. So you'll see, let's say we get down to 160 taxes, 160 government spending, and we've got a balanced budget. Taxes just equals government spending. T minus G equals 0. And if we continue to go up the range of incomes as the level of income in the economy rises, we would see tax revenue would be 220 that particular period of time, but government spending would still be the 160 because it was autonomous. So we'd end up with a budget surplus of 60. Taxes minus government spending is 60, a positive number. So let's pull a few other key things out of here. 60 is autonomous taxes. And we know that because if income were 0, we'd have to collect 60 taxes anyway. And that's sales tax, property tax, fees, that kind of thing. So we start and understand that autonomous taxes are 60. Okay, now we see that induced taxes are 20. What does that mean? Well, that means as income rises by 100 there, taxes rise by 20. Income rises by 100 there, taxes rise by 20. So we've got this induced taxes of 20. All right, now we can calculate the marginal tax rate because we know how much tax will go up with a given change in income. So the marginal tax rate right here is 20 over 100. You can see that taxes went up 20 when income went up 100. And of course, it's a straight line. So taxes goes up 20 again when income goes up 100. So the marginal tax rate is 0.2 in this case. And it will also be the slope of the tax function when we get there. So let's actually build this thing now, the tax function. Remember, like anything else, it's going to have the autonomous and induced component. So here's our autonomous taxes of 60 right there. And we know that the marginal tax rate was 0.2. So the induced component is 0.2 times y. Recall that that induced component has the marginal propensity to import just in front of a level of income to show that as income changes, overall taxes will change by that fraction of it. And here we show that marginal tax rate indeed, where taxes goes up 20, income goes up 100, 20 divided by 100, go back and see the formula, is the marginal tax rate. So now we've got our complete tax function. Here it is, taxes is 60 plus 0.2y. There's the autonomous component and the induced component. And here we show it very, very clearly. Autonomous taxes is the 60 and the 0.2 is the marginal tax rate. 0.2 times y, that's the induced tax component of the tax function. So let's graph the budget line and the tax line and see what we can draw from it. So on top, you can see that the brown line right here shows our government spending at a level of 160. So that's our government spending that we've drawn. It's autonomous, so it stays the same at 160, even as potential income in the country increased. And then we draw the tax function on here. So like others, 60 is the autonomous, so it intersects right there at 60. That's the autonomous amount. And then the slope of this line is 0.2. So once we've got that, we just find out where government spending and taxation are the same. And that's a balanced budget. Right there at an income level of 500, we see tax minus government spending equals 0 because they're both at a level of 160. Now, if we want to draw this line on the lower graph, if we actually want to graph T minus G, in other words, graph the budget, we just take this tax function above here, the blue one, and subtract from it the government spending function, which is the brown one. So there's our line. Right here, the budget line is actually T minus G. So all we did was take the tax line from above and subtract government spending. So it shows balanced budget right here where I drew it, and they're pointing to here, that's fine, as well as down here, because this is showing that the budget line is 0 at that equilibrium income level of 500. Now, one thing they haven't pointed out is sort of a second level understanding. What if we're at really low levels of income, say 300? It's not too much to imagine that taxes aren't going to be crazy large, but government spending is still the same. So government spending is higher, taxes are lower than government spending there, so we have a deficit. Likewise, down below, all it's showing is we took T minus G down here, plotted this line, so this here is a negative in negative territory, so this also is showing deficits. So we go on the other side now, if we go up here, so a national income, if it's way up super high, it's not hard to imagine that government tax received is going to be pretty good because income levels are so high. It's way up there, but government spending is down here. So since taxes are greater than government spending, that shows a budget surplus. And likewise, since we plotted taxes minus government spending down here, if I come down at that same level we were looking at, we see that our budget line is in positive territory. So that's showing surpluses. So that's the complete picture graphically of what we're looking at with this tax function and government spending. Shows how to read a budget surplus, budget deficit, where the budget is balanced, gives us that information. Okay, now we have to take a little bit of a pause and do some tricky math, not too tricky, but now we have to understand that we've got taxes. So that means we introduce something called disposable income, or YD. Before, when we didn't have the government spending in our simple model, we didn't have taxes, so we didn't have to talk about disposable income. But now we need to change things because we can only consume out of the money we bring home in our wallet after we pay taxes. Nobody gets to carry all their money home from their paycheck. You only get to carry home after tax income. It's called disposable income. So we have to take the national income of the country and subtract personal income taxes. So we end up with this thing called disposable income, and it's simply taking overall national income of the country and subtracting taxes. So we're going to play with this a little bit and come up with a new consumption function, and it'll change the numbers on our big table, but the concept is the same. So here we go. We know disposable income is Y minus T. So it's overall national income minus taxes. We just brought this formula down. Well, we also know our tax function. If you look on the previous slide, it's 60 plus 0.2y. That's our tax function. So we just plop it in there. Then we work it through. We end up solving for YD, and we see that that's minus 60 plus 0.8y. So you can go ahead and work through that and prove to yourself that now we have this disposable income function. Well, here's the interesting part. Consumption used to be out of national income. That's how we looked at it in our simple model. So this is the one thing that is different. It beefs it up a bit. Now we know that consumption has to be spent from your disposable income. So what we do is we add that concept right here. Our consumption function used to be C is 50 plus 0.75 Y. But now we know we have to consume out of disposable income, right? After tax income. So 50 plus 0.75 times minus 60 plus 0.8y. That's our disposable income. So when we work through and solve for it, we end up solving for consumption, and it's 5 plus 0.6y. So back that up a bit. C is 50 plus 0.75 YD now. That's a change. It was Y before. So all we do is we simply take YD and substitute it in there. YD we solved. Then we work through and we say consumption is 5 plus 0.6y. That's smaller than the other consumption because now, of course, we're paying taxes. So our consumption is got to be smaller. It's got to be limited. Some of our money goes to taxes. So that's our key point. Consumption is now lower with taxes. So we can see this on the table here. We've got national income, we've got taxes, and now we've got disposable income because we take taxes out of it. And that makes our consumption and savings functions different than what we saw in the simple model. But the concept is still the same. We can see that consumer spending starts at 5. Where national income is 0, there's still some autonomous spending at 5. Now let's figure out our induced spending. Well, all we have to do is take a look at changing national income, like we do here from 100 to 200, and we see that consumption increases by 60. So the marginal propensity to consume is 0.6. which is 60 divided by 100. If you go back, you can figure that out from previous sections. So now our new consumption function is different. C is 5 plus 0.6y, which is exactly what we got in the math on the previous slide. So now we just have to do the same thing with savings. And I know I go through it relatively quickly here, but it's because we've done this same concept several times so far in this course. Savings now starts at minus 65. So that's when income is 0. Savings is minus 65, or dis-savings. You'll see that savings is also less now that we've got taxes in the picture. And that should be intuitive. Once we start paying taxes, means we are able to save less than we used to. So it starts at minus 65. And now what's the induced or the margin propensity to save? Well, here we show income going up 100. And as income goes up 100, savings goes from minus 45 to minus 25, or dis-savings. So savings actually increases by 0.2. That's the margin propensity to save. So now we can actually write out our formula. Savings is the minus 65 autonomous dis-savings plus 0.2y. That's the induced component. 0.2 is the margin propensity to save. When you multiply it by y, you get the full induced component. So if we sit back for a second, it should make sense that when we added government spending and taxes in particular into the picture, then our consumption function has to change and it gets smaller. It gets to be lower amounts, but so does our savings function have to change. It gets smaller because some of the money that we earn goes to taxes. Okay, let's just take a look at the whole picture and see that we find an aggregate expenditure equilibrium the exact same way we always did. So here's our picture. All we have to do is find out where AE equals Y. That's the expenditure equilibrium condition. It's where AE equals Y. So there's no new special treatment or anything like that. The expenditures equilibrium now, including government spending, we just simply find where Y equals AE. And if you're wondering how you figure out AE this time, we used to do it C plus I. Well, now we expanded the model, so it's C plus I plus G. So I add my consumption, which I said is lower than previously because taxes gave us a lower disposable income. I add my investment, which is autonomous, so it's the same as before. I add government spending, which is autonomous, so it's the same as before, and I get AE. Then all I have to do is go down and find out where AE equals Y. It happens to be at a higher level of expenditure equilibrium at 600, but you see that the concept is exactly the same as our simple model. We just added government spending now, so it just changed it by a little bit. If we were to draw the lines on a graph, it would look exactly the same as what we did before, only the AE line would be including government spending, so it would be in a different position on the graph. If we were to do the math, where we actually had the AE function, the function would be a little bit differently, but we'd still solve for aggregate expenditure equilibrium by using the Y equals AE mathematical condition. So there's not too much change when we expand and add the government sector. Although I admit that's easy to say. So go back over and read through this one, view this one again, and just see that you can understand the basics of adding the government sector, what its changes, but convince yourself in the end that you still go where Y equals AE in the table, where Y equals AE in the mathematical formula that we haven't even done here, and you go where Y equals AE if you were to graph it. Now, when we add the export sector next, we'll do all those things. But right now, let's look at the other way we check equilibrium, and that's by leakages and injections. With the government and taxes being included now, we have to add the taxation leakage and the government spending injection. So this is an injection, government spending of 160, investment of 75 is an injection. We add those together, we get 235. Now savings is a leakage, and taxes are a leakage. At the equilibrium level of income, when we add those together, they also equal 235. So our equilibrium level of income was 600, remember, where Y equals AE. So we just added those numbers, injections here, leakages here, and we find out that leakages does equal injections, right? Everything will work out the same conceptually as it did before. So that's it on adding the government sector. Right here, there's an exercise that we may go over in class, but I would ask you to find it in the textbook or in the slides and work through it. You've got a tax function and a government function, and you just have to calculate the budget balance, which they show you is just taxes minus government spending, and they give you certain income levels. So those income levels, that's Y right there. That's the income level. So you plop 400 into this function, get taxes, and then you subtract government spending from it to find out what the budget balance is. And there's your government spending there. So that's it for this section. In the next section, we're going to go on and look at adding the foreign sector. And then we're just going to tie it all together to show you once and for all that there's not that much difference when we use the full model than when we used the small model. And we'll see you when we get there.